Hi everybody, welcome to my technology channel. It's been a while since I have launched my video, but today I would like to start a series of videos related to this topic called DED, Directed Energy Deposition, which is a part of additive manufacturing process. And today we're gonna look together and understand what is DED, how it's used, and what advantages it has. Stay tuned and let's look together on the future of additive technologies. What is directed energy deposition? And what is a laser-based directed energy deposition? Today we're going to learn about this technology, little bit of basics, roots, and the properties which it can offer to the market. This is the first video to give you an introduction, and in my next videos we're going to go and deeply analyze different aspects of this fantastic technology. First of all, it's always important to understand where does the technology belong. And directed energy deposition, it's clear, an additive manufacturing technology. What is additive manufacturing? I believe it's important, first of all, to understand how the additive manufacturing technology differentiates from, let's say, commercially and conventionally available technologies. Classical examples of conventional technologies are formation, where you have a liquid metal which will be injected to any type of press form, which then will be cooled down and helps you to produce a component of an end-shaped geometry. You will probably little bit need of machining, and then you have your final part. To formation belong technologies like casting. Another method of parts, components production is subtractive manufacturing. In this case, you take a big piece of a block or cylindrical body and start to machine it down to a final geometry. That's you can do with combination of technologies like turning, milling, drilling, and even cutting. In opposite to that, if we talk about additive manufacturing, what is a fancy thing about technology is that we build a component during the process, doing this layer by layer deposition of a material. So in opposite to standard technologies, you do not remove a material, you add a material to build a component. And directed energy deposition is an additive manufacturing method which enables you layer by layer build a component by adding an extra filler material. If we look on landscape of additive manufacturing technologies, there are many different methods, mostly belonging to the powder bed fusion type of process. However, here we are focused on directed energy deposition, and we're gonna look on two main methods how directed energy deposition using laser as an energy source is used in industry, and it is powder laser energy deposition and a wire laser energy deposition. Before we try to understand the technology, let's take a look on roots together. And the roots to directed energy deposition are all with laser cladding. And as you know from my channel, I quite a lot explain what is laser cladding. Anyways, let's repeat and see that in laser-based directed energy deposition, we use laser as an energy source. And we focus this laser on the surface of our component or substrate or previous layer, and then start to add there a filler material. So basically, if laser is focused on the surface, it starts to generate heat in a very defined area. It's getting hot, you produce a melt pool, and you add to this melt pool an additional material in form of powder or wire. This is a classical laser cladding. So how does directed energy deposition differentiate from it? Well, very simple. Instead of building coatings on substrate, you start to build multi-layers ending up with a 3D geometry. And this 3D geometry also can be called a component or even a final product. Then you cut it away from a substrate and get your final product. So directed energy deposition is nothing else than a laser cladding technology, but focused not on the coating, focused on production of 3D geometries. There are a couple of other names which you can find on market, including LMD, laser metal deposition, and LPD, laser powder deposition, and a couple of more. I personally like laser metal deposition as definition, but at the end of the day, the only differentiator factor is abbreviation. At the end of the day, we always talk about the same technology where you have a laser as an energy source, where you have powder or wire as a filler material, and then you build parts or coatings with it. You maintain the same process advantages as you always had by laser cladding, including metallurgical bonding with a substrate, and with each individual layer you put on top, you always have a very small dilution between the layers, which is also important if you want to maintain same properties on each individual layer. And then you're 100% dense. Yes, you might have some porosity inside your microstructure, but you have your process parameters under control. We typically talk about dense structures, and their mechanical properties are very close to the bulk mechanical properties. Sometimes you can even take forging process as a reference for the quality of directed energy deposition. Sometimes it might be required to do heat treatment to achieve certain properties or take off some stresses, but at the end of the day, we talk about dense process. If we talk about specifically DED advantages, in my opinion, we should focus on three of them. And the first is that it is possible to repair your components. That means if you do a mistake during process, you can always machine a certain area away and start continuous rebuilding of it. Secondly, we talk about high material efficiency. So if we work with powder nowadays with nozzles, you can get up to 90% of material consumption, ending up in very high deposition efficiency. If we talk about wire DED, we consume 99% of material, and this is an extremely high number. So it's a very efficient and sustainable process in terms of material or raw material usage. I will give a detailed discussion about differentiation between powder and wire in my next lecture. And finally, what is important to understand about DED, you have no size limitations except the limitations of your equipment. You need to build a component 3 by 3 meters width and length and the same in height. Well, if you have a machine enough large for that, you're not limited in terms of technology. And this makes directed energy deposition as a very attractive process. How does it look? We kind of have to look on this slide, an example of how DED with wire is working, and then you see you generate a heat input and then you melt, for example, your filler material, and it looks very nice. You have really low heat input. Now, as you learned what is DED, I hope it gives you an idea and also understanding what are the main takeaways. First of all, it's a very agile technology which helps you not only to build parts but also repair. So if something goes wrong, you can always machine down and build it again. From another hand, it's a very cost-efficient process because you can work with wires or even powder materials where the material consumption rate exceeding 90%. And last not the least, you are limited only with the size of your machine. So if you want to build 3 by 3 meter parts, you just have to enough large machine to make it happen. I believe those main features of technology open a lot of new horizon for a process which is at the same time cost efficient, attractive, and also will target more and more people to join the journey of additive manufacturing using DED technology.